Okay. Hello, everyone. It's awesome to see this many people in the room actually wanting to learn how to build an MVVM-based architecture that works. Before we get started, can we just do a hand exercise? How many of you guys are developers? Good. Okay. So the rest of you who did not put your hands up, you're going to be pretty screwed in about 2 minutes. But for the devs, this is going to be fine. Next one. How many of you guys are doing MVVM-based applications today? And you are here because of... seriously, guys? No, yeah. Okay. Good to know. My name is Chris Klug. I work as I think it's senior consultant at a company called Active Solution in Stockholm. We build custom solutions for clients based on the Microsoft platform. I have a fairly extensive background in Microsoft technologies, doing pretty much everything within their platform. I managed to get myself a Silverlight MVP a couple of years ago. I'm still a Silverlight MVP, so take it in. We look like this. We do exist. We're not that many. As I said, I'm also from Sweden, so if you've got issues understanding what I'm saying, tough. Not really anything I can do about that. So the talk today is actually a view into my messed up head. That's a scary place. I've been there many times. I'm there very often. It's not a place you want to be in, but the thing is that there are good things in there as well. It's not all screwed up. And it's based around what I've learned about building MVVM-based applications for the last 5, 6, 7 years, something. And actually, when I got started doing Silverlight development, I very quickly got into the habit of doing MVVM, and I got very interested in doing MVVM. I started building my own MVVM framework. I am still building my own MVVM framework. It's probably never going to be released. I am trying. I've got it on Codeplex. I've got it on GitHub, but I haven't so far actually published anything that anyone can download. But I have a heavy interest in MVVM, and I've tried out so many different things. So I decided to make this session about taking all the things that I've learned, or the bits of pieces that I've come up with, saying these are the bare essentials that you need for doing MVVM, and also adding in a bit of doing MVVM cross-platform. How can we get MVVM to work on Windows Phone, Windows 8, WPF, and Silverlight? So how many of you guys have seen this statement before? Or seen Shuhari? Anyone? Hands up. Sweet, there's one agile developer among us. This comes from the agile world, or actually it comes from Japanese martial arts. I do not speak Japanese whatsoever, but it's basically, if you translate it, it means first learn, then detach, and finally transcend. In the agile world, they took this up and they basically said, this is the way that we learn things. This is the way that we work as developers, and this is the way that we should learn and start doing new things. At the shoe level, you basically follow your master. So doing any form of martial arts, the first step of learning martial arts is having a master that will teach you what to do, and you will blindly copy whatever that master does. There is no questioning, there's just doing, just following, blindly following every single move that you're told to do. That's what we do as developers as well. That's the first step of learning something. It's following what everyone else is doing. It's going out on the web, finding a blog, seeing how they're doing it, and copying off what they're doing, and then we move on to Ha. The Ha level is where we start going, I get this, I understand this, what's next? So in the martial arts world, that means that you realize that I've learned what my master have told me. Are there other masters out there that can teach me more, teach me other ways of doing the same thing? Are there more than one way to solve a problem? In the development world, we have the same thing. That's when we start looking at different ways of doing the same thing. We start looking at patterns. We're looking at what are other people doing and how are they solving the same problems in different ways. And finally, you have the re state. When you come to re, that's when you transcend beyond all of that. You start building your own stuff. You start going, I don't care what other people are doing. I'm doing it my way. I'm proficient enough in this technology to do my own thing. So how many of you guys are martial arts experts? Okay, not a single one. How many of you have seen The Matrix? Okay. So let's dumb this down. We'll remove it from martial arts into the Matrix. You know Neo? He comes out of the Matrix. They plug him in and they teach him martial arts, among other things, by basically copying off what he can see on these little discs. Then he goes into the simulator and he meets Morpheus. That's your HAL level, when he starts fighting Morpheus and learning different ways of doing the same thing that he's been taught to do in the SHU level. And then finally he becomes the one and everything goes green and stuff like that. And that's when he goes into the real level and figures out, I can do this on my own. Makes better sense than my Japanese martial arts? Cool. Okay, so I started preparing for this talk a while back, and I went into Google. And I started writing architecture is. I don't actually know why. I just have to figure out what it was. And the first thing I get up is architecture is dead. That kind of killed my talk. Made me a little bit cranky. Felt that that's not a good thing. The annoying thing is I then went in and I didn't look at Islamic history or any of the other things. I found something else. I kept typing and found what I needed. Then I came back to Google and I wanted this picture. Google has this adaptive search thingy. You think I can get this screen ever again? No, because it's figured out that I don't think architecture is dead. So I actually needed to find someone else with a computer where they had never searched architecture is before, and then I got that screen. So if you go and search this and you don't get the screen saying architecture is dead, that's just Google knowing that you don't think so. But to be perfectly honest, I really don't think so. I believe that the architecture of an application is the differentiator. It's the thing that makes your application stand out, become the part of application that's easy to maintain, that does all of this complicated stuff that it needs to do, but still keeping it in a sane state where someone taking care of it and maintaining it can still do that. It is the difference between the crap that you build when you just started building software and the stuff that you build when you have 10 years of experience and you've seen all of the failures along the way. Having that said, I'm not saying that just because you're new in software development, you suck at writing code. But the thing is, to me, knowledge is just the sum of all the failures along the way. The only way to learn something is to fail. Architecture is something that grows out of failure. It's something that grows out of, I'm trying to do it this way, it doesn't work. How can I solve this in a way that actually works and I can maintain it? Unfortunately, it comes at a price. Architecture is not free. There's no such thing as a free lunch. Architecture is the same. It becomes complex. It becomes harder to read. So you have to decide when you start building your applications, do I want something that's simple to build, or do I want something that's simple to maintain? Because those two are actually not that completing together. It's hard to build something that's easy to maintain, but at the same time is really easy to write and easy to understand. Architecture will pull you towards the maintenance part of making it more complex but easier to maintain, while pulling you away from simple code. So when you start doing all these layers and all of the architecture stuff and you start looking at your application and abstracting away things and adding in a bunch of interfaces and dependency inversion and all of that, all of a sudden doing your code is not that easy anymore. I've seen myself opening up projects at our office, and I see this little interface. It's like, okay, there's something being done on this interface. F12, oh, that takes me to the interface. Control F12 will resharper. Take to implementation. Go to implementation. Implementation, do one line of code, call another interface. Fuck. Okay, Control F12, go to the next place. Another interface. You keep going. You just keep going deeper and deeper and deeper down the rabbit hole. Interface, implementation, interface, implementation, interface, implementation. And so all of a sudden, you're so far down the hole, you're just sitting there going, I have no idea where I started. I'm just going to go and have a coffee and start over again. You need to find somewhere in the middle, something that's architecturally sound and makes maintenance okay, but not so complex that it becomes hard to work with. There's an awesome blog post. I can't remember where I found it, but there's someone writing a hello app world. He's just writing a simple notepad document and uses csc.exe to compile it. And it starts out with console.writeline hello world. And then he keeps going, oh, no, that's not abstracted away enough. I need to abstract this, and I have to be able to change that. And all of a sudden, he's got 15 or 16 classes in a massive project, and the end result, there's about 15 or 16 lines of configuration, and then at the end, it says hello world on the console line. We need something in between that. So MVVM is a way to get sane logic into our UI and getting our application working. MVVM has this perfect fit into the XAML world. It's built completely around XAML. It's built around the idea that we can do data bindings. Without data bindings, we can't do MVVM. So the normal way, if you start up a new XAML-based application in Visual Studio, you get this awesome project which puts all of the logic in the code behind file. You can't put it there. I wouldn't recommend it. You will even see a lot of blog posts, a lot of information online saying that, oh, XAML and C# is great because they're really separate concerns. They've taken out the code and put it in a separate file. No. That's not the same thing as actually putting in and separating the concerns. You're still putting code that's coupled to your view completely. So they come up with MVVM, and they started adding one layer in between. So you got the view. The view talks to the view model without knowing the view model whatsoever, and the view model gets some form of model with information that needs to be shown. So considering how many of you are doing MVVM today, I'm pretty sure you all know this. I'm not too fond of this implementation. I actually tend to add one more layer in there when I show it off like this. I don't like the idea of having my view models running off and doing service calls and getting the model, or going off to disk and getting the model, or doing anything like that. I do not want my view model to be coupled to wherever you get the model from. So I always add another layer in there, a service layer that will be responsible for getting the model for me. So if that means that it can run off to web services, it can run off to some REST-based stuff, it can run to disk, I don't really care. But doing it like this, I can separate out those pieces, and I can then mock them, and I can test my view models. So for people in here who actually know me, which is luckily not that many people, I don't test anything. I'm not a big fan of testing stuff. I don't know why. I love saying that it's cool because you can test your view models. I have written exactly one view model test ever. And I did it in Notepad just to see if it was possible to do. I don't test it. But if you were to test it, you can do it using this. The reason I don't test is that I mostly, or up until now, have mostly worked with prototyping stuff. And doing prototyping stuff, you get something up, you get it working, and then you hand it off to someone else, and they can keep playing with it. And then I've gone ahead, and I've split out and added another little box in here and said, so we've got the model, but I also want to put platform-specific functionality under the services. So anything that touches anything that's platform-specific should be put out in a different file, probably a different assembly, and hidden behind an interface. That way, once again, you can test it. But not only can you test it, it also means that if you put all of your platform-specific stuff abstracted away, it means that it doesn't matter if you're building a store app, or a WPF app, or a Silverlight app, or a Windows Phone app, you can use the same view models. So you can actually have the view models go across the entire board of XAML-based applications without caring too much about how you do things on the platform-specific levels. It means that storing something on disk, like just saving a file, it's really easy. If you're doing like WPF, it's really easy to just in your view model go system.io.file.create and get a file and then write to that. How the heck do you test that? And on top of that, is there any way for you to move that view model from WPF to Windows Phone? No, because Windows Phone doesn't have system.io and can create a file for you. But abstracting that away, we can get around that and we can change it. We can also switch it out and go, oh, I don't want to store files on disk anymore. I want to store it in blob storage. Sweet. Little change the dependency injection, and you're done. So that brings me to portable class library. Another one of these, hands up. I'm sorry, I'm going to have to keep you awake. There are some of you going, I know there's cheap beer and good food down here. How many of you guys are using portable class library today? That is scarily few. Another question. And don't be embarrassed, this is okay. How many of you do not know what portable class library is? Okay. Quick explanation. Portable class library is a way of building assemblies in .NET that limits what you're allowed to use so that you're only allowed to use the namespaces and classes that are available across all the platforms. So you go in and you say, I want to have a new class library. That's a portable class library. I want it to be able to use it on .NET, Windows Phone, Store App, which is WinRT, even Xbox. And it will basically limit the namespaces that you're allowed to use to figure out which ones are available across the board. It removes any kind of platform-specific stuff. It goes as far as removing visibility, which is like an enumerable in some of the frameworks. It's not available across the board, it's out. The cool thing, it means that we can build stuff that we can build in one place and then use across the board. And if we do dependency injection, it means that we can build our view models in portable class library and have all of our platform-specific stuff being injected into our implementations, and we can use those view models across the different platforms. I love saying that. I love standing here, and I love walking around saying it's awesome, you can build the same view models across the board. It is awesome. Then I have another part in me. So on Friday, the last session on Friday, I'm going to be very lonely though. I'm talking about design and designer-developer workflow. If you're building a WPF application, that is probably going to be very, very different in what you're doing in the UI compared to what you're doing on Windows Phone. There's a limitation on screen size and like being able to do it with touch and all of that. So you're dumbing down your application for Windows Phone. So to be perfectly honest, there are a lot of cases when you cannot use the same view models across the board because those view models will offer way more functionality and be much bigger and more complex for WPF than they can ever be on Windows Phone. So in that case, you're either going to have to split up your view models or find another way of doing it. But the idea behind this is that you can still do it. It also forces this awesome situation where we're going to be building things in the right way. So how many people do TDD? Okay, a few. So that means that most of you are on my side. It's like I don't like TDD, so that's awesome. But the thing is that apparently TDD is growing. Everyone loves TDD. And TDD is just basically a way of forcing you into doing things. And apparently developers like being forced. I don't get it, but apparently we do. This will force you to do the right thing. Because if you start and you do the view, and the view will be platform specific, because however much you want XAML to work across all platforms, they don't. There's different XAML in all the different platforms. Silverlight XAML does not play well all the way through with WPF. None of those two work well with store apps, and so on. So basically, you have to have separate views, and you have to have separate views based on the screen limitations and that stuff I mentioned before. So you put that platform specific, you put it in a project for that platform. Then you do a portable class library in which you put your view models and your interfaces for your services. You know the awesome part of doing that in the portable class library? You cannot, and I repeat, you cannot whatsoever in any freaking way manage to get platform-specific stuff into your view models. It will basically just tell you, cannot be done. You cannot add a visible enumerable as a property because it's not available. It will force you to do the right thing. Then you take the service implementation and you make those platform-specific for obvious reasons, because they are service implementations for that platform. That's okay. And then finally, the model you put in another portable class library. Once again, forcing you to only use types that's available across the board. Doing this will force you into an architecture where you're not muddling the lines. It's clear, separated, and you can move the different things across the platform. So even if you're not being able to do your view models across different platforms, you can at least have your model slide across the different platforms. And when you get started with framework or MVVM, there's always the question of, oh, so Chris, what framework are you using? I love that question. I keep getting it. I get it every time I talk about MVVM. First of all, I want to mention that MVVM has got nothing to do with any form of frameworks. MVVM is just a pattern. You can do MVVM without putting any form of framework in there. But frameworks will help you. And there are some really good ones out there. If you do ask me what frameworks would I recommend, I would say you can do MVVM Lite, which is really awesome. It's very close to what I like, the way I like working. You got Calibre and Micro, which is good. Microsoft Patterns and Practices just released another framework, which I'm kind of annoyed about, because it pretty much copies my framework completely. So my idea of releasing my own framework was just stomped to death by Patterns and Practices team at Microsoft. So Prism would be an obvious choice for me if I were to choose a framework. The scary thing about doing frameworks is that you are limited to the guys working on that framework. New version coming out of your software, or new platforms, like update to Windows Phone, can't touch that until somebody updates the framework to support the new platform. Update to Windows Store apps, can't touch any of the new features until your framework is updated. So you are sort of in a scary place with frameworks, which is also why when choosing frameworks, you should consider looking at what's the situation with the dev team behind it. Microsoft Prism, they have patterns and practices team at Microsoft. You know that they will be working on it. However, they've been pretty slow so far, so I don't know if that's a good thing. But they do have staffing. If you look at MVVM Lite, you've got Laurent working on that. He's pretty much alone. Being that, he's the fastest guy I've ever seen working on a framework. When they released Windows 8, the same evening he had a beta version of his framework working on Windows 8 at build. That was ridiculously fast. Let's just think about it. Do we want to go down there? And if you do want to go over a framework, just go to NuGet. Get your framework, install it, you're done. That's it. And you get all the help that you need. Or you build your own. That's what I've done. I do not recommend building your own in most cases. Building your own is just stupid. It takes lots of time. I used to spend more time building my MVVM framework than I did building actual implementations for my customer, because every single customer case needed some form of change or addition to my framework, so I spent like 5 hours on that and 2 hours building a feature. Not a good thing. And you've also got plain vanilla. Skip framework completely. I talk a lot with a guy in Stockholm that basically focuses on only building store apps and phone apps. He does WinRT all the way through. He doesn't touch frameworks anymore. He's basically said, I'm just removing it. There's just too much of a hassle having the frameworks in there. They limit me. What I do is, well, he's got it. He does sort of a bunch of features in one project, and then when he goes to another client, he copies over those features. He makes them a little bit better, and if the previous client has enough money to pay for it, he will basically take that new feature and port it back to the other client. So he tries to keep all of his clients on a sort of similar level, but he does copy C# files back and forth. I would probably prefer doing my own framework, but even though it's a small one. But the slide is all about, don't just necessarily say, I'm doing MVVM, I need to find the best MVVM framework. There are differences to it. Okay, so if we look at the things that I figured out that's most important when building MVVM-based applications, this is my favorite thing, dependency inversion. Or in my case, dependency injection, because I do dependency injection, and IOC containers. How many of you guys are using IOC containers in your projects today? It's actually not that bad. It was way less at TechEd US. I was a little bit scared about that. There were basically no hands coming up, so either they were sleeping or they weren't actually using them. Dependency inversion is great, and you do have some options for it. I just want to highlight that, and I'm going to show you a little code and showing it. Singleton as an option for dependency inversion. How many people love singletons? There are like 3 hands coming up, 4 or 5. How many people have heard that singletons are dangerous? They're scary things you should never touch and never include because they will fail your test. You will not be able to test it. Yeah, completely wrong. So singletons are okay. You can do singletons, you can do static variables and all that. It works, but you have to do it in a specific way for it to work. Factory methods, not a great way of doing it. Have a way to create a class or an interface or whatever through a factory, and then you can at least just change the factory and you're done with getting your application out there. Service locator is another great pattern for finding all of your services. There's a good one from Microsoft Patterns and Practices team, the common service locator, which is basically just abstracting away your IOC container. So you're putting an abstraction on top of your abstraction on top of your implementation. That's what I was talking about, the whole architecture thing. When you start doing an abstraction of an abstraction of an abstraction, that's when you start thinking, do I really need this? Service locator is good, and then you Google it, and there's like 1 million people out there telling you that you're stupid because service locator sucks. It doesn't suck. It's a good pattern. So don't listen to that. And then finally, you have dependency injection, which is what I prefer using. I prefer having an IOC container, and I prefer injecting my implementations into my class instead of me having to go and ask for them through a service locator. So I'm going to see if I think there's I thought there was a slide saying demo. I'm just going to show you a little bit of code showing you how you can do that in a useful way. Okay, so I can't use my own screen, so I've got the screen over here, and I've got my computer here. So if and they built the podium for midgets. So look over here. So I've got ISA. The code that I'm showing off here is on my blog, so you can just go and download it. It's just that I didn't feel like standing here and typing like a million lines of code, and I don't like snippet programming. So I just thought I'd give you a pre-built project, and I can show you some code instead. So I have this little project here. It's basically every folder is supposed to be a solution. And we have a little client here that we can run. I'm not going to run anything. I'm just going to show you code. But there is a little client here. There is some implementation. So here is my actual implementation of the Is It Holiday service. It's the Swedish holiday service. It will tell me if it's a Swedish holiday. And apparently, we only have days on top of this 5 weeks of vacation we get. But the important thing here to see is I've got this little thing. Actually, let's go in here to my view models and look at singleton view model. That's the one. So this is what I'm talking about, singletons. People are scared of doing the whole static variable thing or static property. So I've got isitholiday_service.instance, which returns an isitholiday service. It returns the interface. Once again, I'm not locked down. This is fine. And then I have a method called isitholiday. And if we look at the implementation of this thing, it actually has an abstract base class, or an abstract class, which has basically an instance variable that adds static. And then there's the implementation of this one. And as you can see, it's got a public static initialize method that basically just sets the base class's instance variable to this. So in my applications class, I basically just go in and I say Swedish holiday service.initialize. And that will set up the instance for me. If I want to test this ever, I can just build my own stubbed version of this and make sure that it inherits from Is It Holiday service, the base class, and that it sets the instance one, and I'm done. There's no coupling to any specific classes. You're not breaking your test. It's fully testable, but you still get your static properties in there. Make sense? It's awesome, because if I'm going to say, is there anyone not getting this out there, there will be no hands going up. There's still going to be about 25% going, I have no clue what this guy's talking about. Especially the guys that are apparently not developers. The IT pros in here is going like, where's the next finish button? Sorry, I didn't say that out loud, did I? Okay, so that slide in the beginning that said, welcome to my messed up head, that was just my messed up head doing something. So the other thing is we can do let's look at what I want to show. Oh, it's a factory method. So a factory is a different way of doing things. So the factory uses another class with a static method called create. That will make it possible for me to manage lifetime of my objects. So in this case, if I look at the implementation of this, once again, it's an abstract class with a static initialize method, but it takes a func. So basically, it takes a callback that I can use to create a new instance of it. So in my application class, I basically just say, is it holiday service factory dot initialize, giving a factory and all of that, or a function for creating it. The better way with this is that you have very good control over lifetime of your objects. So you could be returning new objects all the time, or you could return singleton objects, or you could keep lifetime based on threads and stuff like that. And once in a while, that's actually a very useful feature. It's also the stuff that makes it hard to debug and hard to figure out when something goes wrong. But it's a good way of doing it anyway. Then the simple service locator. Why am I in? No, actually, that's the one I wanted. So the simple service locator is a really stupid, it's like it's a singleton version of a class. And if we look at it here, the class is a public class. It takes an isitholiday service and then has one property for each one of the services that we need. It's just simpler to go simple service locator dot current dot isitholiday service than having a singleton class for each and every one of our services. Then there are a couple of people now going to say that, well, if I inject this with a bunch of services, I'm going to give my view models access to a bunch of features and a bunch of services it should not have access to. So I'm like breaking. They could go ahead and do something they're not allowed to. May I just ask one thing to the people saying that? Who are they? Because to me, that would be my code. So they would have to be my, I don't know, evil twin or my schizophrenic other me going in and just manically, I'm going to touch something I'm not allowed to touch. Seriously, guys, we're just talking about a way to get access to services in an easy way. Whether or not you feel like doing the wrong things in your view model, I don't really care, but this will give you the option of doing it in a simple way. So you just go and you say simple service locator.current.isItHoliday service, and you can call the method. Just a very, very simple way of doing it. The slightly more complicated way is using a proper service locator. So a proper service locator is built on the same idea of a static property called current, but it uses a resolve method. It's a generic version of it, where I'm basically saying, can you give me this service? I give it the interface, and it returns the implementation to me. It just means that we don't have to create a property for each one of the services. Instead, we have this generic thing where we can go and say, can I have this? Can I have that? That's apparently better. I have no idea why that is better for the people saying that you might touch things you're not allowed to touch, because it allows you to touch just as many things. And the implementation of it is just simple like this. It takes a creator function like I had before for the factory method, and then in resolve I just use that and say, can you give me an instance of this? I could also have this wrap an IOC container, which would be much easier, but I didn't want to include that right now. And yes, I'm like pushing through this. There's lots of code, I know. If you don't get the whole gist of it, just download it and have a look at it. It will give you some time. And I think these sessions are actually recorded, so you can listen to my annoying voice when you get home as well. And then there's this. This is what I do pretty much every time I do a project. And I'm not kidding. It's like every time I do, even the simplest little piece of project, just to demo things, I throw an IOC container and dependency injection into my project, and I set it up like that. Even doing like little blog posts, actually I never do little blog posts, but even doing just a little thing for a blog, showing off a very simple process, it hurts inside of me not doing this. I don't know why, but it just simplifies all of it. So I've got this view model here, and it basically just says, I need an ISITHoliday service. Figure it out, not my problem. It's like, I need that, you give it to me, and I don't care how you do it. There's just one problem with doing that in view models. If we look at the general views that we're using, we're going to any one of these. Let's do factory one. There it is. If you look down here, this thing says data context equals VM factory view model. That initializes a new instance of factory view model. There is no way to do dependency injection inside of that. It will just give you a new instance of that class using a default constructor. If you ask for parameters, you're screwed. So the way you get around that is implementing something called a view model locator. It's like a service locator, but from view models. And you put one of those. I'll show you the implementation later. But you basically put one of those in your appsaml.cs file to make it available to your entire application. Then inside of this view that uses it, you do data context equals, and then you bind it to a property called dependency injection view model, which is the view model that I want. And I set the source to my view model locator from my resources. That way, I've actually offloaded the creation of my view model to a separate class in a very nice and simple way. I even get like IntelliSense in here. So using the property binder thingy from Visual Studio will even tell me, oh, there's a view model locator in your appsaml file. Do you want to use that? Yes. What view model type do you want? And I just choose that, so you can even do it graphically. And offloading it like that means that my view model locator, which is down or up, no, which is here. The class looks like this. Once again, I'm not using an IOC container. I'm just using a creator function. But it has a property. So I do one property for each dependency or each view model type that I need. And inside that property, whenever I ask for one, I'd use in this case, the creator function to create it. Normally, I would use an IOC container to create it. So getting dependency injection into your view model means that you have to add that separate layer of stuff in between to do the dependency injection for you. But once you got it, you can just code away. It's just so fast. It takes seconds to get a new view model up there with all the dependencies you need, and it's just there. And on top of it, it means that whenever you look into a view model, you know exactly what it's doing, because the constructor will define everything it uses in there. So it's easy for you to figure out what is this view model doing. So that's different ways of doing dependency inversion. You have to go there. I'm sorry, but it's the only way for you to move forward to get testable view models, getting separation of concerns, and getting everything going nicely. View model to view communication. Okay. View to view model is a lot more complicated than view model to view. View model to view is fixed by doing just data bindings. View to view model can be done using two-way data binding as well, so you can get it up into the view model. Once in a while, you do end up in a situation where you need to access the view model from your code behind. There are scenarios when you do need to add code behind to your XAML files. I know we want to keep it as little as possible, but when we end up in those situations, there are ways of doing it. There's the good, the bad, and the ugly. So you want to choose the good, and it's actually not that complicated. So if we look at doing that, let's go in here and see view model, view communication. Here it is. Wrong button, that one. So I got this simple view model. It's just it's a really stupid example, I know. So I got this view model. It needs to save a file. I don't want my view model to go to system I/O and ask for a new file. I want to make sure that the file is given to me in some way. I want to stream. But for some reason, I don't want to add another service. So I've decided to do my data access or my file access through my code behind. So it's got this save method here. One way of doing it, which is what I see once in a while, and every time I see it, I cringe, and I hope that I can ever become Freddy Krueger and come and kill the person in their sleep. It's just not a good way of doing it. If we look at this thing, the view basically just has a save click or button, and you click it. And then you go, oh, let's take my data context and just cast it to my view model. And then I'll do a file save picker thingy. I will use my view model, and I will call the save method, giving it a stream, and I'm happy-go-lucky. Anyone do things like this before? Nobody will admit that now. You're all going to be scared of falling asleep tonight. The thing with this is that the whole idea behind doing MVVM is that the view should not be coupled to the type of the view model. You should be able to switch them. You should be independent. They should not be coupling each other. And as soon as you start doing as my view model, you are coupling everything up. You're binding your view to your view model so solidly that there is no way for you to switch it out. I hate this. It's actually not that hard to do it the right way and do it in a good way. The other way of doing it is defining an interface. Down there. I have an I-saving entity. Basically just saying, I have something that can save stuff. It takes a stream, and it needs an action to return any form of exception if something went wrong. Having that in there, and implementing that in my view model, I can, in that case, do a slightly nicer version of doing it, where I cast my data context to I-saving entity. That is way better. That is actually decoupling it in a nice way. So I said I had the good, the bad, and the ugly. This would be actually the not so bad. It's quite OK. But I'm still coupling my view model to an I-saving entity. So I'm still doing a little bit of coupling. The next one is the kind of stuff that apparently blows people's minds. And I don't know why, because I'm just so used to it, I don't react to it anymore. I've created a save command that implements I-command, which is the standard way of binding up commands through view models and views. I just implement the functionality up here of doing the save stuff. In my constructor, in my view model, I set the save command. So I've taken all of that code and just put it into a command like this. And then, in my code behind for my view, I basically create, I need both of those. I create a dependency property. So dependency properties is what we use to do all of our data binding. So just create a new one of those. And in the constructor, I say, I want to bind that dependency property to save command. It's the same thing as do a curly brace binding syntax in your view. It's just that we're doing it in code behind instead. It's the same decoupling. It's the same thing of I'm identifying the command with a string called with save command. That's it. Then when I come to the save click, I just make sure that there is something in there. Have I actually bound it? Is there a save command on my view model? If there is, then I can go ahead and do my code. This is a brilliant decouple strategy to get that functionality without putting in any form of coupling whatsoever, except for the dependency on a save command property on my view model. So how many people did not get this example? Be honest. There are a couple of hands coming up. Okay, so it takes a little while to get your head around, I know, but download the code and play with it. It's actually a great way of doing stuff, and I end up doing that once in a while. It's one of those few things I think is okay to put in your code behind. View model to view model communication. How many of you have view models that talk to other view models? If you keep those hands up. How many of you are doing that using events? None. Oh, a couple. How many of you are doing that using callbacks? A few. How many of you have something like an event aggregator? And what the hell are you guys doing here? Like, if you're at that level, putting in event aggregators and all of that, this should be a piece of cake. So for those of you who are not doing it, communication between view models is really, really important in a lot of cases. This is what I need. Because we have these views where we put like a bunch of, like a whole graph of view models in there, or we have separate view models in different parts and stuff like that. If you've ever built a Prism application in WPF that dynamically loads up modules where different modules need to talk to each other, that's one of those typical examples when you go, ooh, how do I solve that? It's actually not that hard, but I'm going to show you the 3 ways of doing the communication. If we look at that thing, wrong button again. Look at the view models. We can do the event-based stuff. That's not what I wanted. I want that one. So the event-based stuff is kind of annoying. So in this case, I've got an email client, which is an email client view model, and it creates a bunch of emails, or it has a list of emails. And every time somebody needs to reply to an email, I need to tell another view model that, hey, this guy wants to reply to this email. So doing it here, I'm just creating my view models sort of hard-coded. But as you can see, I need to go in here and I create my view model, like one view model for each of my emails. But then after that, I have to go through each one of those and say emails.reply requested plus equals on reply requested and hook up my event handler like this. And then whenever the email view model has the button for reply clicked, it needs to raise the event and all that. That works fine. Does any one of you know exactly how garbage collection with event handlers work? Like specifically, what keeps what in memory, what gets garbage disposed with handlers hooked up? If you don't do this. You really need to disconnect these as well. So you must have a way of disconnecting your event handlers to not have a memory leak. And doing view models where you don't really have knowledge of when your view is being loaded and unloaded and stuff like that by default, it's hard to know when do I detach my handlers. So be a little bit weary about this one. You can introduce some quite serious memory leaks using it. Now there are a few people out there going, oh, I wonder what I've just done. I'm going to go home and rewrite everything. It's generally not a problem, but it can be. The other version is doing callbacks. Exact same sample. But instead, my emails get a callback passed into the constructor in this case. And it's just an action, or action that takes an email. And I can then from my email view model say, hey, callback, I need you to do whatever. This is a little bit better because you don't get the memory leaks in there. Because it's just the email client is holding a reference to its parent, not the other way around. So the parent won't keep them in memory. So this is a little bit nicer, and it also means that we don't have to, if we run off to a server and we call down all of these 100 emails, we don't have to have another for loop in there to set the event handler for them. Instead, we can just do this while creating it. So that's an okay way of doing it. But both of those samples require the communication to be going from a child view model to its parent and then back down to another child or somewhere else, or just upwards. There's no way for me to talk sideways. So the email view model has no way of talking to the reply view model. I have to go through a parent. So if we're building anything that's modular, where different parts of the UI doesn't know about other parts of the UI, there's no way to do that form of communication. You're going to be screwed by the fact that you don't have a common parent. You can have all of them have the same parent. You're going to have this God class that has every single view model in your entire application in there. And then that has like this 400 million different things for handling this kind of event and that kind of event and that kind of class and that kind of... And you can probably build something really nifty using generics and stuff, but you're going to get screwed in that anyway. So it's kind of limiting. The solution to it is using what is called an event aggregator. So for some brilliant reason, I decided to switch view models and switch the UI for this demo. But it's pretty much the same. There is an inbox view model in this case instead. It does the same thing. It creates email view models. No callback, no events, no nothing. Just get the view models, give them a model to display, in this case an email, and you're done with it. If we look at the email view model, it has a reference to services.eventAggregator, which is my event aggregator class, though, .current, so it's a singleton, and then .sendMessage. Then I have created a new class called a reply requested message. So for every type of event I want to raise, every time the kind of thing I want to put out there and tell someone to do something, I create a class that basically defines what I'm wanting to do. And then I just shove that out there. I just throw it out. It's like when I went to school, you would sit this hallway with different rooms in it, and once in a while, like the teacher would just put her head out the hallway and yell and hope that somebody further down, one of the other teachers, would hear her and solve the problem or come and help her. It's kind of the same thing. You just throw it out there, and you have no idea if anyone is picking it up. You don't really care. You're just going to go, I need somebody to reply to this email. Here's the email. Go figure. I don't care. The other end of it is the guy listening to it. This guy. So he goes, in his constructor, he goes and gets the event aggregator, and he says, I want to register for this type of messages. So I'm listening to these messages, and whenever one of those is called, I want you to call the on reply to email, and it takes an instance of that message, and then I can go from there. So these view models are now completely decoupled, and I could literally remove either of them, and neither of them would break. You wouldn't get a working email client. You would either not be able to reply, or you would be able to reply but not see any emails to reply to. But it will still be completely decoupled. Implementation-wise, I know most developers go, oh, how is that built? It's just, there are little extra classes with message registration objects that keep callbacks and types and things like that. And whenever a message is sent, it goes to a dictionary for that type, figuring out who wants to have messages of this type and calls their callback. It's actually not that hard. This is in the code download. Do not use it. That's the kind of guy I am. I'm that giving, sharing, loving kind of guy that will give you code and then tell you don't use it. There's a little issue with this one. It will give you a memory leak. There, I said it. What you want to do when you're doing this is you want to make sure that that list that keeps references to all of the other listeners uses a weak reference. You do not want them to have a firm reference to that object, because any object that will ever register for events or messages will never, ever be able to unload it, and you will introduce a memory leak. So either get weak references or make damn sure that you unregister for those messages whenever your view model is being released. And don't do it in dispose, because you will never reach dispose, because you're going to stay in memory. So you need to find out another way. There might be one of those awesome frameworks that I know a guy that built, that put their codeplets, that might have a good implementation of that might be released sometime in the future. Stay tuned. There is also an implementation on my blog that you can use which has weak references, I think. But basically, when you start building your applications, look at these patterns. When do we need to communicate? Can we do it through callbacks, or do we have to go as far as introducing an event aggregator? It's not hard. And if you do choose to go with MVVM Lite, I know that Laurent has an event aggregator in there, so it's just pre-built. You can just start using it. Oh, that was the one that I was supposed to fix after TechEd US. So that's asynchronicity, not asynchronicity, apparently. How many people, once again, hands up, people are falling asleep. Let's just keep everyone on their toes. How many of you guys are 100% comfortable doing asynchronous stuff? 3. And those people, keep your hands up. I want to see this, because this is interesting. So how many of you would keep your hands up if I said you're not allowed to use async await? Oh, a few of you. OK, so. But the major part of you go, no, I don't like that. You have to go there. With WinRT, you have to go there really bad, because there's nothing in the framework that's synchronous if it's possible that it can take more than 50 milliseconds. And apparently, people have slow freaking hard drives, because reading a disk is apparently supposed to be possible to take more than 50 milliseconds. So even reading a file off your disk is an async behavior. So you have to do it. And especially when you reach out into view models where everything is on the UI thread, you have to be asynchronous. There are a couple of ways of solving asynchronous behavior. There is the idea of doing callbacks. Callbacks used to be the preferred solution before they did async await. And then they said an async await is awesome, we'll do that instead, and it just makes everything simple. Like, I'm just going to say this method is async, I'm just going to wait it, and everything is fine. And to be perfectly honest, if you start looking at IL code, it's just syntactical sugar. But it helps you out a whole lot. There are some issues with it, though. The main issue with doing async await is actually the last thing on the right-hand side that says NuGet Microsoft BCL async. Portable class library does not have async support. There is no way for you to put async await statements by default into a portable class library. But if you go NuGet Microsoft BCL async, they will magically add that feature to you. And it's kind of awesome, because it's actually mind-boggling how they do it. Because we're not talking about adding some classes for you. Well, they are. They're adding the task class. But they are introducing new keywords. They are introducing async await using a NuGet package. That blows my mind. It's just awesome. I've figured out how they do it, and it's not as mind-boggling as you think. But it is kind of cool, though. So there's that issue. And there is one more. Things like callbacks for progress. Asynchronous things are cool because they can go off and do their thing. But if you've got a long-running asynchronous job, don't you generally want to know when it's done? You generally want to have some form of progress, saying I'm 50% done, 60, 70. Or if you're using Windows 7 and you're copying a file, it's 50, 40, 45, 30. You want to have that, and that's actually a little bit complicated to do with async await. You need to introduce some other stuff to get it done. Actions, on the other hand, are really brilliant. They offer some really cool stuff. And also, one thing that I don't have here with actions is you can call them many times. So you can call a method and give them an action, and you can have that action being called over and over and over and over again, while async await expects there to be one asynchronous thing, and then it's done. So as with previous slides, I have some code for that. So let's look at asynchronicity. So I've got this calculator service that apparently calculates some heavy stuff. That's what my calculator does. Implementation of it is fairly irrelevant. So there's 2 versions of that, I thought. OK. Implementation of it is basically just a way of a thread.sleep. It's just you don't have thread.sleep in WinRT, so you have to do this complicated manual reset event thingy-majig to get it to sleep. So I just told it to sleep for 5 seconds. So that's the base of everything. If we look at my view model for simple callback view model. So this is the way you write a callback version of it. I get the calculator service callback, which is a callback version of the calculator, and I call calculate some heavy stuff. I give it an action that takes 2 parameters back, and that's another sweet thing with callbacks. They can take as many parameters back as possible. That's it once. So I'm taking a result and an exception. So if something goes wrong while doing my asynchronous stuff, I catch that and I return that exception. So exception handling for this is basically in my callback, I just go, if exception not equals null, return. You should always just, when you get an exception, just return. Client won't notice. They will sit there and wait for you to do something. But so a lot of my code comes out like this. And apparently Martin showed me some code from Azure as well. They used to have / om nom nom. And that was what they did in their callback or in their exception handler. Don't do this. It's just a demo. You do need to handle exceptions properly. And then if there's no exception, I've got a result, I can use that result. If you have many things that you have to do asynchronously, but sort of in a chronological order, you just do another one in here. So you get this little thing going in and in and in with tabs or space or whatever you use. And it's fairly easy to follow along what's happening at every single step. Scott Hanselman apparently calls it the cone of death. Because it becomes like a cone, and when something goes to shit deep inside of that, it's pretty hard to figure out where. And depends on how many levels you do, but it's fairly easy to do. But even though I like callbacks, it is pretty hard to beat this. Var result equals await, calculate some heavy stuff. Yes, that is much easier to read. Exception-wise, try catch around it, and you're done. So it's, for simple things, async await is really, really hard to beat. And you can't get around it. It's just there all the time. But if we have a look at that idea of doing progressive callbacks, basically being able to progressively tell the user that, hey, I have now done 40% of it. I've now done 50, which is something that we should put in, if possible, everywhere. It looks like this for a callback. So I go progressive callback.do progressive work. I give it 2 methods instead, 2 callbacks. One callback that takes the progress and updates the progress property on my view model, making it possible to data bind to whatever progress I've got in a progress bar. And a second callback, which is, here is where I'm getting the result, and I can get the exception in there as well. So that's actually not that hard, right? That's easy to understand. Callbacks is something that we're kind of used to. And it's a heck of a lot better than having events for everything. It's like, oh, I'm going to do this thing, and then I'm going to hook up for these 2 events, and when I'm done with everything, I need to unhook these events, and I have to do this, and I have to do... This is just very, very simple and easy to work with. One thing to note, though, threading. Remember that when you're doing stuff asynchronously, you generally end up on a different thread for all of your callbacks. So make sure you have a way of making your callbacks marshal back to the UI thread so you don't get one of these invalid cross-thread something exceptions. And I'm saying this because I got an invalid cross-thread something exception building this demo. There are, like, if you use there used to be a class called background worker. Background worker will make sure that all of your progress gets called back on the right thread and doing all of the marshalling for you and all of that. Once you start doing this, you're kind of on your own. So you have to make sure you do it right. And I think I've got some code in here actually doing that. No, let's just ignore that. We'll look at that later on. Yeah. So for a task, it's actually a little bit different. We have to introduce some form of reporting our progress back. And luckily, they introduced a new interface called iProgress of some type. So if I create one of these progress reporter that implements iProgress of int, and the only thing that thing has, it uses another callback, nicely enough. It basically just calls back with the progress. And it's got one method called report. So what we have to do is, in the place where we do our work, we have to create a new progress reporter, another class, and then we go to our task-based implementation of the do progressive work. I can do an await there, for the result, but all of the progress has to be reported through that other class. So I need to create a separate utility class and pass that in, and then my implementation can go ahead and call back on the reporting thingy here. So it's a little bit more complicated. It includes creating a new class and all that, and you can actually end up with quite a few of those classes unless you make them very generic. So it makes it a little bit more complex when you start sort of edging closer to the line. And it also, you end up with some situations where async await will screw you when it comes to marshalling threads and stuff like that in certain scenarios. So it's not all just fairy dust and unicorns. OK, so it's obviously not that hard to do asynchronous work anymore. And then there's one more thing that I keep coming back to, and that's there are certain abstractions in our different platforms that we do need to handle. And as I said, every single platform abstraction should be an interface and then a specific implementation of it. And some of these actually work, or all of them pretty much work across the board when it comes to XAML C# applications, but they are implemented differently. So navigation, for example. Really simple thing. They all navigate in the same way. They navigate like web-based stuff. You navigate through pages and views. There's like backwards and forwards and all of that, like a browser. Unfortunately, WPF, Silverlight, Phone do that using URLs or URIs, while Windows 8 decided, or Store apps decided that we want to do it using types. So all of a sudden, we cannot use the same implementation there either. We have to abstract that away. We've also got the dispatcher. So when we start doing asynchronous work, and I start talking about marshalling stuff back to the UI thread, you need to have access to the dispatcher. Where do you find the dispatcher? Well, you find the dispatcher in your code behind. The least useful place to put it. Most of our environments do have a way of accessing the dispatcher in a static way. So you got package.current or instance or current or whatever dispatcher where you can access it. But you need to find a way to abstract away your dispatcher as well to be able to come back to your UI thread when you do asynchronous work. So those two are things that are in every single application I ever build, kind of. And finally, I have another pet peeve when it comes to building XAML C# applications, especially store apps. They have an application class that your application will start running from that is really complex. How many of you guys are building store apps today? Like a few hands coming up. So how many of you guys can tell me exactly what events and what callbacks and what things are being raised in the suspend, resume, terminated, started kind of thingamajig with the whole suspension stuff going on in store apps? Anyone want to give me a try? Because I would love to have a chat with anyone that can explain that to me in a good way. Because they've made that slightly complicated. And when you reach complicated points in your code like that, every time you start a new project, you have to go to the reference documents and figure out what things are being called when and where and what are not called, build an abstraction for that as well. So I suggest abstracting away the application class. Prism from the Patterns and Practices team is doing exactly that. So if you use that, they have a better abstraction for it. So I have some abstractions here, like those three, that I think are interesting to have a quick look at. So if we start with dispatching, there's an iDispatch service, which is just an interface with invoke. It looks pretty much like the dispatcher. And then in your app SAML file, you just hook that up or you create an implementation of it. Sorry, you go in here and you go to services and you go to it's down in that one. Dispatching, dispatch service. It takes a dispatcher. So in your application file, you have to go in when it starts up, get a hold of a dispatcher from your core frame, give that dispatcher to this service, and that will do the marshalling for you. That will solve that problem. There is another way of doing it that I kind of like. If we look at the iThread marshalling service, it looks exactly the same. Implementation is a little bit different. So it doesn't require me to pass in a dispatcher. Instead, when you create it, and this is sweet, you know that all of your services will be created on the UI thread, right? Because they're going to be created in your application class. So that's going to be on your UI thread. You can pull out a class called synchronization context. How many of you guys have worked with that before? A few. Cool. So synchronization context is basically saying, can I get the context for the current thread? And then I can use that to send things back and keep a reference to that context and get things getting marshaled back to it. So I don't have to get the dispatcher. I can just go ahead and get the current synchronization context from the UI thread, and then I can use that to post stuff back to that thread. That just makes it a little bit easier to set it up. You don't have to pass things around. You just create an instance of it. Navigation. I generally create something like this, an iNavigation service, which is really simple. It just has a go-to, another go-to, and also another sweet feature of this thing is that it makes it possible for us to pass a dictionary of values between one view and another, not just a query string that's limited in size and only can do serialized data. You can actually pass objects. Because once again, you've got this master object sitting on top of everything, sitting there and marshalling everything. And he can then say, oh, you want to send that to this guy. That just makes it easier. And the string I've got here is the key. So basically, every view that I want to make possible to navigate to, in my application class, I register it using another interface, which is called an iConfigurable navigation service, which implements iNavigation service. And I basically say, for this key, use this type. That works for Windows 8. For Windows Phone and all of the other platforms, you have to do string URI. But basically, you're giving them a dictionary version of saying, this key means this view, and then you navigate between keys. And that also means that if you want to change the flow of your application, you can just switch out views as you want to, because the view models will say navigate to a view with this key, but it doesn't know what view to show. It's just going to say, go somewhere, this is the key, do whatever you want. So whenever we want to change the flow in our application, we can just change the key values and we're done, or the views for those keys. I also generally have a go back and a can go back, and for Windows Phone, generally you have a can I go back several steps? Can I go back until this key? Because navigating backwards is awesome, but if you're doing this flow where you're doing a couple of pages of forms or whatever, when you end up at the end of it, you do want to navigate back. You don't want to navigate forwards to the home page again, because if you start doing the back button on your phone, you go through the entire steps of your form. So you need to go navigate backwards to a certain point, but the navigation service by default doesn't have that. So by adding this other navigation service that I've got on top of the original one, we can modify the back stack and we can make changes to it and give ourselves some new features. And finally, the last thing I've been mucking about with, which actually came out of doing this presentation, is creating an MVVM aware application. This is my favorite abstraction for a long time. It inherits application. Unfortunately, you do have to inherit application. You cannot create this like a bootstrapping separate class. It does have to be inheriting your application. And what it does, it basically sets up all of this stuff. It handles suspension. So it's got on suspend and on resume. It's got handles activation with on launch, on activated, on search activated in this case, because I can actually get this charms handling into that same base class, which makes it fairly easy to work with charms. I've only done search so far, but it works. And a little bit with on window created and things like that. I've got application management stuff, or lifetime stuff, with launch, rect, suspend, resume, activation. I set up my IOC container in here. The cool thing is that this class it looks pretty specific, but it's actually very general. It's specific for store apps, but it's general enough for me to pull into every single store app I ever build. And for those of you who have never seen a store app before, the XAML, or app XAML CS file is about that long. It's got loads of, oh, actually, no, I don't, I do have one. Let's see. It normally looks like this. So So it's got this, and this is the simple version. There's a lot of comments in there, I know. But if you choose one that actually sets up suspension handling and all of that, which is called there's another template for it, they add like, it seems like 500 lines of code in there, handling suspension events and resume events and hooking up certain services and stuff like that. If you build your own abstraction on top of that, basically taking their implementation and making it generic, your applications, your app SAML files, can become something like this. There is an, well, actually, you have to have that one for it to read your SAML file. You have to override this if you have any services that needs to be registered for IOC container. In this case, I do. And you need to implement what is the first view that should be shown in your application. In my case, it's main page. The other stuff, like the activation target, I've created a little thing here where you can implement iSearch suggestion provider. So when you're doing search using the charm stuff in Windows 8, you can say that my application will do search suggestions. So whenever you start typing it, this will drop down with suggestions. To implement this with this kind of abstraction, I just implement iSearch suggestion provider, which is just that simple. It's basically a task-based provide suggestions and a one that says, so you have this suggestion, where do you want me to go? So basically translate this tag into a view that I can navigate to. With that abstraction that I have, you add that, you implement those two things. In my case, they're implemented using a separate service to get the stuff, and I append a query and stuff like that. And I have a way to say that for that tag, go to this page. But there's nothing in here where I need to hook it up. The base class will handle all of that for me, saying, if I am a search suggestion provider, I will handle everything for you. I will hook everything up, and all you have to do is build the actual functionality, making it a piece of cake to get your new applications up and running. And that's the thing. Whenever I start building a XAML C# application, I don't want to spend half a day building the basics. I don't want to spend a half a day setting up my frameworks and my dependency injection and my this and my that and my everything. I just want to say, I want to inherit my other class, do a reference to that assembly, and I'm done. Then I can start being productive. Because I don't know how many of you are working with like products as such, but I work in a consultant agency. Our clients do not want me to spend half a day or a day building something like that. They don't want to pay 1,000 euros for me messing around with something that I've done 100 times before and setting up like boring stuff that don't give them anything. That should just be out of the gates, here, one little change and I'm done. I've got 2 minutes and 30 seconds if there are any questions. I want to, for those of you who do not have any questions and want to head out of here, I just want to thank you for coming. I hope you got something out of the session. I will be available here for a couple of more minutes for questions. Then I'll be down at the booth for Windows 8 at the Expo at 2:15, I think, if you have any other questions. And if you see me running around the halls and you have any questions, just grab me, ask them. I'm happy to answer any questions that you might have. And don't forget your evals. Evals are good. They give me feedback for everything that I need to change. So don't be shy. Do evals. If you like the session, say that. If you don't like the session, forget about the evals. Just skip that part and I'm happy. So thank you, everyone. That's about all I had to say.